start. Hello, welcome. Thank you for coming to my talk. We only have 35 minutes, so let's go and don't waste time. Just a few words about me. I'm Dirk. I studied informatics at Aachen, or in Aachen. Now I'm living in Bielefeld, and I'm managing director of Guidoplan. We're doing consulting and training. And for many, many years, since around 1999, it's always Java, enterprise Java, so application servers, Java EE, Jakarta EE, Spring Boot, Quarkus, and so on. Yeah, for the time of this talk, let's assume that we are deeply familiar with Java EE, Jakarta EE, depending on when you started with this. So we're using application servers like Whitefly, JBoss, Pajara, WebSphere, and build our applications with, for instance, JPA or Jakarta Persistence, CDI, JAX-RS or Jakarta REST Web Service, and so on. So that's our comfort zone. And we have done this for many, many years and built up reasonable knowledge in that respect. And now there came new requirements, many from the cloud or microservices, self-contained systems, and so on. Where the original idea of the application servers, I think, was you have a big server and put many applications on that, but we don't use that anymore. We have just a server and one application on it. So we think we could make that simpler. No server deployment pair, just one application. It should be small or lightweight, whatever that means. Memory footprint, quick, easy to develop. Yeah. Then it should be configurable, some kind of auto-configuration, and then in the cloud we want to configure our applications with environment variables, for instance. Then we need our applications to be observable, so the cloud environment can judge if our applications are running well and perform well. We can use metrics to, for instance, scale the application or raise alerts or something. We want to have it quick starting, means it can be easily scalable. We want to connect our applications to many third-party softwares. So we need a large ecosystem to use cloud infrastructure or messaging infrastructure and so on. So these are new requirements for the last 5 or 10 years maybe. And now you talk to your colleague and they tell you that you have to use Spring Boot for that. Now we have a simple project set up with initializer there. It's an embedded server, so you don't have this server and deployment pair, auto-configuration, configuration with YAML files, environment variables, and so on. Development is easy. You have dev tools, testing support. Testing in enterprise applications is a ambitious task. So that's easy in Spring. So there's simply no alternative. And you think now, well, with my knowledge in JEE, do I really have to switch to Spring Boot now to fulfill all these requirements? Is that the only way to go? Is there really no alternative? Well, there have been alternatives for many, many years, but they haven't got that market share that Spring or Spring Boot have. Like Cumulus EE. Maybe, does anyone of you know Cumulus EE? One. So it's the name says it. It's a cloud framework based on Java EE, but not many people know it, so it's not used anymore, I think. I think it's not even developed anymore. But in 2018 or 2019, it changed. That was the time when Quarkus was released the first time. And Quarkus is a framework from Red Hat. And I think if you want to name it that, it's Red Hat's answer to Spring Boot. It's not the first try that they had. They had the Whitefly Swarm, later renamed into Thorntail. That was the first try, but tooling wasn't good enough. It was not fun to develop applications with that framework. So that's abandoned, and now we have Quarkus, and Quarkus is a real alternative to Spring Boot. And it's based on Jakarta EE and MicroProfile. So we can use our knowledge from that space. The framework is optimized for short time to first response, not just booting fast, but the first response to a REST call, for instance, is optimized, and is optimized as well for low memory footprint. And it runs on a standard Java virtual machine. Many people think you can use Quarkus only to build native applications. It's not the case. You can run Quarkus applications on your Eclipse Tamarin or Oracle OpenJDK, for instance. But you can also compile your applications into native code to make them even smaller and faster. The slogan on the website is Supersonic Subatomic Java. Well, that's marketing, but I think it's true. To judge if all these requirements that we had on the last few slides, if they are fulfilled only with Spring Boot or also with Quarkus, I prepared a short feature matrix. We don't have much time, and I want to demo it, so I just picked a few respects from there, and well, we'll try to build an application with Quarkus for that. So simple project set up. If you want to start a project with Quarkus, you have three alternatives. You can use a website for that. You can, well, click your application together and download a zip file then. That's near the same that Spring Initializer does. So the website start.spring.io. That is the one for Spring, and Quarkus is, I think, code.quarkus.io. It's nearly the same. You can use your favorite build tool, your Maven or Gradle, or you can download a command line utility and build your application with that. I picked just the Maven way. So that would be wrong history. There's many parameters here. That's just to make it easy for me now. You could start the create goal from the Quarkus Maven plugin just without any parameters, and then that would ask you for that. But I've just prepared it a little bit, so it's quicker enough for here. So that initializes an application into a new directory, which is named the same as the artifact ID of the Maven project. And that's a simple but full Quarkus application with a little bit of sample code in it. We can just have a look into it. So the project setup in Maven is nothing special. If you compare to Spring, we have dependencies here for various parts of the application, like a REST provider and a injection provider and test support and so on. In Spring Boot, it would be named starters. Here it's extensions, it's the same. And you have a plugin in the end that has the task to build a startable jar file from your application. Yeah. So that's the same structure that you have in Spring projects. We can guess that they have looked into each other's code. Yeah. So it's the same principle. If we build the application, it's just Maven package. In the end, there was a run of the Quarkus plugin that does a so-called enhancement of your application, where some of the decisions that normal applications do at runtime are made at build time. So that's part of the optimizing to reduce the starting time of Quarkus applications. The application is now in target. Yeah. Quarkus app. We don't have time to go into detail, but there is a startable jar file and some subdirectories where dependencies lay on, and this startable jar file is just in the end a class path manifest. That's it. So if you want to start the application, it's just starting a Java SE application. And you see, well, it's a tiny application, so we won't judge from this quick start time for normal applications, but it's really fast. 0.7 seconds for starting the framework with this little application. From other frameworks, we would expect something around 5 or 6 seconds. Yeah. That's the effect of this reducing the startup things that normally get done by reflection. So the application has just one REST endpoint. I can call it with curl, for instance, or the browser. It tells us hello from Quarkus REST. Okay, and the important thing is that these things like REST resource classes and endpoints, that's just standard Jakarta EE code. It's nothing special for Quarkus. It's Jakarta EE. Yeah. And the same holds true for injection, for persistence, and so on. So you don't have to learn something new to program your application. You can stay with your knowledge. I think that is important. Okay, so we have simple project setup, nothing special. We have an embedded server. What is Tomcat and Jetty in Spring is Vertex or Undertow in Quarkus. Vertex normally, Undertow is a full-featured servlet container, so if you want to have that, you can do that as well. What's quite nice with Quarkus is that you have a really nice development mode. I'll start my application into that now. It's a Maven goal or Gradle goal or whatever your build tool has or is. Now the application is started in development mode and works the same as before. So the hello endpoint answers hello from Quarkus REST as well. But if we change something here, hello OCX, and request the endpoint again, then we see the change has been compiled and reloaded into the application. that is triggered by this external request. So it's not done every time when we change the applications, but when we request it from outside, or we can use a hotkey in the dev mode as well to reload the application. There are two reloading mechanisms. You can stop and restart the application, that's the default, or you can use instrumentation, so every class is wrapped with a class loader, and if it's possible, only the class is exchanged. Yeah. So that's the thing that Zero Turnaround does with its tool. Yeah. So you have that built into dev mode of Quarkus as well. So that's simple and easy. And well, it's important to mention that the dev mode does not rely on anything of your development environment. I use Visual Studio Code here, which has a Java extension, but I don't need that. Yeah. The dev mode of Quarkus observes your source code. It's built into your build system, so Maven does the thing, not my development environment. Yeah. Okay, so we have a nice dev mode. For the remaining 2 points, dev service and continuous testing, we'll have to do a little bit more. Maybe for testing. Testing is difficult in enterprise applications. If you want to have some application server or so, then you have to have something that does the run of the application server and deploy the application and run the test code and so on. That's easier for frameworks like Spring or Quarkus. Quarkus uses JUnit for testing, and at Quarkus test, the application that you see here is a JUnit 5 extension that manages the life cycle of your application. So if you run one of these test methods here, your application is started, the test is run, and the application is stopped after that. Yeah. And even more, you have injection possibilities here. You can inject beans from your application to look into your application, so you have black box testing using only external interfaces, white box testing, go into your objects and test their status, and well, every combination of that. That's easy. And what's very, very nice is that I could start this test method now just as I'm used to it in my IDE. But even better, I think, is I can use my dev mode. I can run the tests in my dev mode. So while developing my application, I can use a separate instance of my application for testing in the same window. And well, the test is red here because I changed the text that the REST endpoint publishes in the end, so the expectation is not met. And if I correct my code now, so go back to my original version here, the tests are normally they just run at the time when I save it. Why not? That's a test. That's a test. I have to change this. Yeah, okay. So, hello, Quarkus REST from Quarkus REST. Now the test is run again, and in this little application we just have one test, but assuming we had 1,000 tests, then only those test methods would run that were affected by the code change that I did. Because the Quarkus plugin does a code analysis and knows which tests are affected by which code change. Yeah. So that's very quick. If you have a normal development surrounding your dev mode on a separate monitor, for instance, then you can change your application, develop it, and if it's getting red there, you have to correct your code until it's green. So no excuse for not testing. That's really, really nice. Next thing, for that I will extend the application by adding some extensions. I could edit the POM file for that, but there is a plugin as well that can do that. I will add extensions for a database driver, Hibernate, and health checking, which I will use later on. It just changes the extensions, the dependencies in my POM file. And if I start the dev mode now, then you see now that there is a Docker container starting for Postgres. Yeah. With one of the extensions, I requested a driver or an extension for Postgres, and I didn't configure Postgres. I didn't configure any connection URL or user or password, and that triggers Quarkus dev mode to start the database in a container and connect it to the application. That's called dev services. We have dev services for all the major databases and message brokers like Kafka, for instance. ODC providers like Keycloak. Yeah? So the dev services, to make it very, very simple, your entry step into developing applications is made very low. You can develop your application with the database that you want to use in production. Yeah? No such tricks like we did before. Develop your application against H2 database and use Postgres in production. Yeah? You just develop with Postgres, yeah? Because it's so easy. Yeah? These are the dev services. Well, of course, it needs a container environment on your development machine. Yeah. Okay, configuration. We can use properties files or YAML files. By default, it's property files to configure our application. So we can invent some variables like greeting equals hello OCX. Yeah, so that's a property here, and we can use that property in our beans or REST endpoints by just injecting a config property. No. Richtige Ding. So the property was named greeting. And well, injection target should be something, string greeting. And we can use that now. So let's try. Hello OCX. And to show that environment variables are reflected as well, we can use the dev mode with an environment variable. Well, who is German, but just to have a try. Okay, so environment variables are reflected as well. So that's what we normally use in cloud environments to configure our applications. So we started without the extra value here. So we have easy configuration per default with properties, but there is an extension for YAML configuration, and you can have configuration profiles. So you can have configuration for your production mode, that is the run of your application by Java -jar, for dev mode, for testing, and you could even invent your own configuration profiles if you wish. And you can put that into one configuration file or split it up into several. So it's nearly the same than we have that as we have that in Spring Boot. So that's in the end it's the same, and it's supported as well. So last thing that I want to demo is I've added a extension for health checking, and that's MicroProfile health checking, or MicroProfile health. So the endpoint is health/live or /ready, and there is a endpoint or a support for liveness per default. That's just black or white. Yeah? If the application runs, it's up, and the resulting HTTP code is 200, and if it's not running, well, nothing comes. But you could prepare your own checks if you wish, which could easily be embedded into the answer here. And liveness endpoints are normally used for cloud environments to judge if the application is running well, and if not, it's restarted normally. And then we have a readiness endpoint, which is technically the same, but the focus is here on, is the application ready to serve your requests, which is normally used by, for instance, load balancers to route your requests to the application or to some other instance. And what we see here is that there is a check in the liveness endpoint, and that is coming from my Postgres extensions. So the database extensions normally have a liveness check which tests if the database can be connected. You can switch that off if you don't want that, but it's normally in there. So that's part of the auto configuration of these extensions. We have metrics as well. I didn't incorporate the metrics extensions, but if I had, we could use the application to tell us how much memory is used, how much threads are running, how much requests per second we are serving, and you could easily extend that with your own metrics if you wish. Okay, so everything on this feature matrix is fulfilled with Quarkus. So we don't have to switch to Spring for that. And what about the size and the pace of the application? That's a screenshot from the website quarkus.io, where they compared Quarkus applications in a normal JVM mode, that's the blue one, with a traditional cloud stack, where they don't name that here, but you can guess what that is. That's Spring Boot. Yeah. So this little application falls into the just rest part. So my application will be around 73 megabytes in memory RSS size, compared to nearly the double of that in a traditional application. And starting time, we saw that a few minutes before, it's just under a second with a normal application, whereas the traditional stack needs some more time, but it's only seconds, so it's a question if it's really important, but there is a difference. And as I said, you can also compile your application into native code. That doesn't work with every feature that your application has. So the application has to be prepared for being compiled into native code. But if you do that, you get even quicker starting times. I did it before because the building of the application takes 2 minutes around, and time is running low. So I did that before, just to show it. This green one in the middle, the JEE SBT really blah 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 runner executable, that is what came out of the build here for, well, it's an Ubuntu operating system here. And if I start that, it starts in 0.1, so 124 milliseconds. Yeah. And memory footprint is even reduced, so you can, if you use that in a cloud, you can scale up and down very quickly, and you use very low memory. But you are a little bit limited in what you can use in your application. One thing is wrong that we may have heard from others. They tell you that you cannot use reflection in native applications. That's not the case. You have to prepare your application for that. Yeah, it has to embed additional code for that, but you can do reflection. Yeah. Okay, last issue, ecosystem. How many third-party products can I use in my application? And if you want to, you can have a look into the ecosystem on that web page here, quarkus.io/extensions. And there are many, many third-party projects or products that you can use, like messaging providers, Kafka, for instance, or integration tools, Camera, for instance, and so on. There's many, many things. I think around 700 extensions are there and growing every week. So that levels up with that what you have in the Spring ecosystem. So to wrap up, well, there is a server framework based on GEE. Yeah. There always have been frameworks, but now we have one that is on eye level with Spring Boot. The market share, although, is not the same. Spring Boot, roughly 60% of market share, 60, 65. Quarkus, 30, 25 or so, growing. Spring Boot Pros are market share, okay. And ecosystem is even bigger than Quarkus. Well, Spring Boot is older. Yeah. The pros of Quarkus, I think the developer experience is even better. The dev mode is really nice. It's quick. It makes fun to develop Quarkus applications. The footprint is smaller than Spring Boot applications. Yeah. Thanks to the Quarkus plugin that we had there with this augmentation phase, which reduces the code and adds code for what normally is done at runtime with reflection. It's fast, and, well, that's maybe my main point, it's standard. It's Jakarta EE and MicroProfile, and you don't have to rewrite your code to go into a cloud-native application. Yeah. Okay, if you want to read more about that, have a look at our website. There is a blog where we often publish things around JEE and Quarkus and so on. And and yeah, we have trainings, we do consulting. So if we can support you, we're happy to do that. My contact email here is here. So that's my 50 cents about JEE and MicroProfile and cloud. Thank you very much. Are there any questions? Yeah.
So why do you think that after the other attempts that weren't as successful, it is exactly Quarkus that made it? What was the critical factor?
I think the critical factor is the better development experience. This kind of dev mode, continuous testing, dev services, that is really a push forward. With the Frontail project, we didn't have that, and it was very slow to develop applications. So it was not fun. And you need fun to build good software. That's my conviction.
Those managers who decide what tech stack will be used decide on if it's fun?
No, I don't think so. But I mean it as I say it. From the developer standpoint, if you don't have fun to develop your applications, you will not write good code. Yeah. So if they choose to, if managers chose an application stack because of that, I'm not sure of that. But from our standpoint, that's really the case. Yeah. And maybe we can tell them, and they will understand that that is the case. Yeah. Happy developers, good code. Okay, thank you very much. Have a good time on the OCX, and I will be around for all 3 days, so if you meet me, I'll be happy. Thank you.